Okay, course diagram. Right, so in your investigation, you would have seen you had to know the course diagram. Okay, you need to know which is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so here, top right hand corner is quadrant 1. Okay, so quadrant 1. And quadrant 1 is where you have an A. Okay, what does that A stand for, grade 10s? Okay, all trig ratios in the first quadrant are positive. Okay, meaning sin is positive, cos is positive, and tan is positive. Okay. Right, so see here, all trig ratios in the first quadrant are positive. What else you need to take note of is that the first quadrant is from 0 degrees to 90. Okay, so in the first quadrant, theta lies within those two angles. Okay, 0 degrees and 90. Okay, that's quadrant 1. Quadrant 2 is top left hand corner. Okay, top left hand corner. And that is your S in course diagram. In the second quadrant, sin is the only one that's positive. Okay, so in this quadrant, sin is positive, however, cos and tan are negative. Okay, and what else do we know about the second quadrant? It's from degrees 90 to 180. So theta is going to lie in between 90 degrees and 180. Okay. Quadrant 3 is bottom left hand corner. Okay, and it's T in course diagram. What does that tell me? That in the third quadrant, tan is the only one that's positive. Okay, which means sin is negative, cos is negative, but tan is positive. We also know that quadrant 3 lies between 180 and 270. Lastly, quadrant 4 is bottom right hand corner. It's the C in cost. And that C tells me that cos is the only one that's positive. The rest are going to be negative. Okay, so we've got sin that's negative, cos that's positive, and tan that's negative. We also know that in this quadrant, theta lies in between 270 and 360. Yeah, no, remember, in trigonometry, it can be either theta, alpha, beta. They can even use x, y, z, a, b, c. Okay, just in this instance, I'm using theta. Okay. Another thing I need you guys to take note of that's very important, that was in your investigation as well, is in the middle. Okay, we've got the origin. Okay, it's just a 5-minute bell. The horizontal line, okay, from 180 to 360, just this line over here, it's your x-axis. Grade 10s. From the origin to the right, x is positive. To the left, x is negative. Are you with me? Okay? The vertical line is your y-axis. From the origin up, y is positive. And down, y is negative. Right, are we all okay? Please know this cast diagram off by heart. Cast. Please know this off by heart. Okay. Okay, let's move on. Right, negative angles. It's important to remember that we measure positive angles in an anti-clockwise direction. Okay, so positive angles is in an anti-clockwise direction. Okay, meaning that way. Are you with me? Okay. Negative angles are measured in a clockwise direction, so it's going to be the other way around. Okay, so negative angle is measured clockwise. However, if an angle is measured clockwise or anti-clockwise, it does not influence the trig ratio. Okay, when we get to examples, I will show you negative angles. Right, so for example, if I had to just draw like a rough little sketch here, this would be theta, and this would be negative theta. So do you see positive angles are clockwise direction, negative angles are, and positive angles are anti-clockwise and negative angles are, okay, are you with me? Right. Why do we use the Cartesian plane? Okay, it's in order for us to calculate an unknown side in a triangle, however, it's just on a Cartesian plane. Right, once we have two sides, okay, so we're going to use trig and we're going to calculate a side or other angle in a triangle. If we have two sides after we've used trig in our triangle, what are we going to do to calculate the third side? Okay, Pythagoras. Right, so in order to solve some questions, we need to draw a right angle triangle on the Cartesian plane, which I will show you. However, it needs to be in the correct quadrant. Okay, so what's going to happen is, we're going to give you a question, and you're going to have to use the information in this question to draw a triangle on the Cartesian plane. Once you've drawn your triangle on your Cartesian plane, you're then going to have to use that information to answer the questions that follow. Okay. After drawing the triangle, we use the theorem of Pythagoras to solve for a missing side, and then we'll go and substitute in order to find what we need to find. Okay, so I think the best thing here is for us to go and do an example so we can see what this is all about. Okay. Right. One thing I want you guys to add here. Okay, it's all good and well. That diagram above does show us our cast diagram, but it doesn't show us how each triangle within a quadrant is going to look. Okay, which is very important because you'll most likely get marks for your sketch. And if your sketch is incorrect, then you're not going to get the marks. Okay, so how I like to remember this, I like to remember it as a bow tie. Right, a bow tie. bow tie look? Okay. Okay, just bear with me, it's not drawn to scale. Okay, it's not drawn to scale, but you get what I'm saying, hey? Okay. Fantastic bow tie that, isn't it? Okay, everything else remains the same. Your x-axis stays the same. Your y-axis stays the same. Okay? This is still the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Everything stays the same. And you know in the first quadrant, all are positive, only sin is positive, only tan is positive, and only cos is positive. Okay, so everything stays the same. Remember, trigonometry only works for right angle triangles. Drawing a butterfly or a bow tie does create a right angle triangle. Do you see here it is here? Okay, there's your right angle triangles. Okay, are you guys with me? Your reference angles will be where? Okay, where your origin is. So it's here, 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 and here, depending in which quadrant you're working in. Okay, your reference angle will always be at the origin. Are you guys okay? Yes?
If they give us our angle outside the triangle.
90 degrees minus whatever that is. Okay. Yeah?
How do you know that's the origin?
Because remember the origin on a Cartesian plane where your x-axis and your y-axis cross, that's where your origin is. Okay. Right, so again, this is your positive x. This is your negative x. This is your positive y. This is your negative y. The same on the other side. Are you guys okay? And then opposite your 90 degrees is your hypotenuse. Okay? But when they like to refer to it as a radius. Okay. On the class diagram. So this will be known as your radius. Okay, or hypotenuse, same thing. Okay. Your radius can never be negative. Can a hypotenuse ever be negative if it's the longest side in your triangle? Okay, so that number can never be negative. Okay. One thing I do need you guys to focus on is, do you see your negative x's? So let's say you do Pythagoras and you get 5. But your triangle lies in the second quadrant. Your x is not 5. Your x is going to be negative 5. Okay, so that's just a step extra that you'll have to take. Okay.
Then why do they refer to it as a radius if it's not a circle?
Because what is the radius?
Isn't it like
Yeah, what is the radius? From the center to the circumference where it is. So it's from the center to where it is. Look here. Can I draw it out for you? You to understand. So here's your bow tie. You see it? Isn't this the radius? From here to here? Radius, radius, radius. Okay, understand? Right, can I move on? You guys happy? Are we happy? Right. Right. Okay. Okay. Right, so C is point minus 12 and 5. I want you guys to stop there. And let's just see what they've given us. They've given us a point negative 12 and 5, which is a coordinate. Are you with me? Okay. And a coordinate is made up of x and y. The first number is x. The second number is y. Right, now the whole point of trigonometry is for it to be a triangle. Okay, so what we're going to do is we're going to draw a right angle triangle. Okay, and are we going to connect it this way? Okay, are we going to connect it that way? Okay, how? Because my bow tie looks like that. Okay, so what we're going to do is you're going to go and close your triangle over here. Okay, you guys with me? Okay, so we close our triangle. And we're going to go and write in, we're going to now interpret our coordinates, okay? And we're going to go write it in because that coordinate counts as the distance, the length of each side in the triangle. Are you with me? Okay, so we know that this is x and this is y. Okay, so the distance from here to here, which axis is this? Okay, my x-axis. What is my distance here? Careful, negative 12. Why? Because we're on the negative side of the x-axis. So if you said it's 12, it's wrong because we're not on the positive side of the x-axis. Are you with me? Okay. Right. From here, okay, up is the distance of my y. Okay, which means it's going to be 5. Positive 5 because it's on the positive side of the y-axis. Okay, are you with me? Right, do you see we've got two sides in our triangle? Are you with me? Malema, you look very confused. How can I help you? Right, we now need to go and calculate the length of OP. We don't need to go and use trigonometry. Why? Because we have two sides, and if we have two sides, we can go and use Pythagoras. Okay, so are we calculating the hypotenuse? Yes, so we know we're going to add. Okay, so my hypotenuse is OP squared must be equals to, let's make this point,
Can't you just say x squared plus y
yeah, we can. Yeah, we can, but the thing is, I don't want my notation to be wrong because now I've used OP. So if we're going to use OP, we must use sides, or we must use R squared is equals to x squared plus y squared.
Use Q.
Do you understand? Yeah. So I'm going to just add this, make this Q. I just want to keep my notation the same. Do you understand what I'm saying? I don't want to use now a side and then I use x's and y's and. Okay, so I'm going to make this OQ or QO squared plus PQ squared. Okay, so if you're going to do it your way, it's okay. Right, you could have said R squared is equals to x squared plus y squared. I just want to keep the notation the same. I don't think we'll penalize you, but it's always nice to have it okay the same. So OP squared is equals to negative 12 squared plus 5 squared. So OP squared, oh, we are using Pythag, don't forget your reason. Okay, this is going to be 144 plus 25. That gives me 169. Square root both sides. So OP is going to be equals to. Remember, whenever you square root, your answer is always plus or minus, eh? Do you understand why? Okay, I'll show you now. So it's plus or minus 13. However, I did tell you that a radius / hypotenuse can never be negative. So then you'll say, therefore, OP is 13 units. Okay, so when you square root, why is it plus or minus? Okay, so remember, a square root is telling me, it's the inverse of a squared number. It's telling me that the same number multiplied by itself is going to give me 169. Okay? So if I take 13, positive 13, times positive 13, my answer is 169. That's why your answer can be positive 13. But if I take negative 13 times negative 13, it also gives me 169. That's why when you square root, your answer is always plus or minus 13, because positive 13 times positive 13 gives me 169, as well as negative 13 times negative 13 will also give me 169. Okay, let's just go and write down the three ratios for sin, cos, and tan. Okay, so sin alpha, cos alpha, what's wrong, Umulemo? Tan alpha. Silly of hens, right? So silly, old, opposite, 5, hens, hypotenuse, how much? 13. Fantastic. Okay, cos, cackle, and, how much is and? Adjacent, negative 12, cackle and hop, 13. Good. Together or opposite, 5 alone, 13. Negative 12. Okay, that's it. That's all. Done. Okay, so now listen, this is very, very important. Okay. There's going to be, no. Okay, so there's going to be a hint here for you that's going to tell you you need to work on the class diagram. Okay, and where's that hint? Here. Yeah. It's giving you degrees. That degrees is telling you go and draw a triangle on the class diagram. Okay. 2 pieces of information that are very important. Now remember, a class diagram, you're only going to work with one triangle at a time. Okay? Bow ties got 4 triangles. But now you're going to ask me, ma'am, how do we know which quadrant you're working in? It's going to tell you. Okay? Use the 2 pieces of information in order to draw your triangle on the class diagram. Okay? First piece of information. What are they telling you over here? They're telling you that tan's ratio is negative. Do you see? Tan is negative. Okay, so tan is negative. That's my first piece of information. Are you with me? Yes. Okay, so on my class diagram. Okay, on my class diagram. Okay, so tan is negative. In which quadrant is tan negative?
It's second quadrant and third quadrant.
Are you sure? Okay, so we know it's or a cos. Okay, so here's tan is positive, here tan is positive. So where's it negative? Okay, so I'm going to put a dot here. So it's here and here. Okay.
Is it fine if we draw that before we
Yes. Yes. Okay, so look here. Step 1 is to determine the quadrant to draw the triangle in. That's what we're busy doing. We're busy with step 1. Okay? Right. What else do they give you? They tell you that it's between 0 and 180. Now, where is 0 and 180? Which quadrant is that? Okay, so it's 0 to 180. That means it's here and here. Where do we have 2 dots, great teams? Sin. Not sin, quadrant? 2. So we are working in quadrant 2 because that's where my 2 dots are situated. So we are here. Okay, are you with me? Okay, yes.
Where did you get your second card?
My second dot from here. From 0 to 180. That's my second piece of information. First piece of information, tan is negative. Second piece, 0 to 180. And 0 to 180, my restriction is quadrant 1 and 2. Do you understand?
Yes.
Okay. Which means, how is my triangle going to look? It's going to look like such. Okay, we are working in this quadrant. Yes. So therefore, that's how we're looking. Do you understand? Hmm? No, it's fine. No, it's okay. Yes. Okay, so question was, ma'am, so we don't have coordinates. No, my honey, we do have coordinates. And where does that come from? Where do my coordinates come from? Okay, from the ratio they give you. Here it is here. So tan alpha is equals to negative 5 over 12. And we know tan, what is my ratio for tan? Together or alone. Are you with me, grade 10s? Okay, so we know alpha is here in the middle. Okay, so together or my opposite side is? Okay, but be careful. This is the positive axis. So which means that needs to be positive 5. Are you with me? Okay, so this is positive 5. It's not negative 5 because it's on the positive y-axis. Okay, remember the? Okay, it's not a coordinate. It's, you need to make it a coordinate. Do you understand? So this is your y-axis. Okay, and that is your x. Okay, so obviously now I've showed you, you use your ratio to figure out which is your opposite and which is your adjacent. So together or 5 is your opposite, but it can't be negative 5, it needs to be positive 5 because it lies on the positive side of y. Okay? And my adjacent side is 12. Now adjacent is your x-axis. But this is your negative side of your x-axis. So this must be negative 12. Are you with me?
Yes, ma'am.
Okay? Yes. Right. Now can we go and calculate the third side in our triangle? Okay, how do we do that? Okay, so Pythagoras. So now we don't have A, B, and C, so now we can use R, X, and Y. Okay, so R squared is equals to X squared. We are calculating the hypotenuse plus Y squared. That's going to be negative 12. It's the same as the question above. Do you see? Okay, exactly the same as the question above, just asked differently. Okay, plus 5 squared, so this is going to be 169 square rooted. So R is going to be 13. Okay, so our hypotenuse is 13. Okay, and we use Pythagoras. Okay, but where's the actual question, grade 10s? We need to go and calculate this. This is the actual question. Now you just have to remember, what was the whole point of us doing all this Cartesian plane stuff? Okay, because we need the third side of our triangle. Because silly old hens requires that 13 that we had to calculate. Cackle and hop, it uses the hypotenuse, that third side we had to calculate. That's why we put it on the class diagram. Do you understand? Yes. Okay, so what is my actual question? 3. Okay, what is sin theta? Sin alpha, sorry. Silly old hens. Okay, so this is opposite silly old hens. What is my opposite side? 5. What is my hypotenuse? Okay, that is the value of sin alpha. Do you understand? Okay, sin alpha's value is 5 over 13. No, sin alpha is 5 over 13. Do you understand? Okay, you're basically substituting. Sin alpha's value is 5 over 13. Okay? Minus 2. What is cos alpha's value? Shackle and hop. Okay, my adjacent side is negative 12 over 13. Are you guys with me? So we're basically substituting a value for sin alpha and cos alpha. Yes. 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 Okay, so it says without the use of a calculator, so just do it in segments. Grade 10. So we're going to put 3 times 5 over 13 into our calculators and we'll get an answer of 15 over 13 minus 2 times negative 12 over 13 and you get negative 24 over 13. Yeah.
If we immediately wrote positive like we did it.
If you put a plus there, it's fine. Yeah, that's fine. Okay, so that becomes a plus, so your final answer is going to be 39 over 38. Who of you want to say to me, man, what if I wrote it as a decimal? Who would have you, pardon? Who of you would have written it as a decimal? Let's just say, for example, because 39 divided by 13 is 3. Okay, so this one you're more than welcome to continue. But who of you, let's just say it was 40 divided by 13. Who of you would have said push S to D? Who of you would have done that? Okay, but how do you know that 40 over 13 is 3.07 or 08 without using your calculator? You understand? Okay, so be careful. Because, like, how do you know?
Take out marks.
Yeah, 100%, because your instruction says without the use of a calculator.